Okay, this is the practice test for Chapter 3, and it starts off with banking problems. And the first problem says find the amount P that must be invested at 12% interest rate compounded continuously to end up with $100,000 at the end of 50 years. So since it's compounded continuously, we'll use the right-hand side of the sheet. We're finding the amount that needs to be invested, the P. And so we're going to be on this area right here. We want to end up with 100,000. The interest rate is 12%. That would be amazing if you could get that. And the T is 50 years, and you'll end up with only having to invest $247.87. So in other words, if you invested $247.87 compounded continuously, and you just put this in one time, then in 50 years, you're going to end up with $100,000 if you were to get actually 12% interest. Now, let's say you only got 3% interest. Then you would have to invest $22,313 to end up with that in 50 years. And let's say instead of 50 years, it was 20 years you want to end up with that, then it's going to be a lot more, like 54,000. But anyway, that gives you an idea how much the interest rate and how much your time that you leave the money in there affects it. On problem B, it says that find the amount in a bank at the end of 10 years if $1,000 is deposited at an interest rate of 10% compounded quarterly. So we would just go to over here, $1,000, interest rate was 10% compounded quarterly, so the N is 4. And let's see, how many years was this? Compounded for 10 years, so the T is 10. And there we go. The amount that you end up with is right here, and here's the interest earned. Okay, problem C says, how long would it take a person's money to double if it was compounded quarterly at an interest rate of 3.25%? So what you want to do here is, how long would it take the person's money to double, and it was compounded quarterly? So since it's compounded quarterly, we're finding out how long it takes, that's T, to double. So whatever you put in for P, make A twice that amount. The interest rate on this particular problem was 3.25%. I'll just type it in that way, 3.25%, and let's see, it was compounded, it says quarterly, so the N is 4, and so the answer to this problem is 21.414 years. Okay, problem D says, how long would it take a person's money to increase by 30% if it was compounded continuously at an interest rate of 3.25%? Okay, compounded continuously, so we're on the right-hand side. How long would it take? So we're here at the T. Now to increase by 30%, so whatever you let your P be, let the A be that amount times 1.3. And that will be 30% more. Okay, so if it's 100, it's 130. If it's $1, it's $1.30. The interest rate on this particular problem was 3.25%. And you can either type it in with a percent or move your decimal place over. And we get 8.073 years. Problem E says, what annual interest rate would you need to receive so that your principal increases by 50% in 5 years? Okay, what annual interest rate? So I'm over here on this side right here. Now we're finding out the rate to increase by 50%. So if you have $1 in here, we're looking at ending up with $1.50. So whatever you type in for P, make A 50% more than that, or multiply it by 1.5. Now on this particular problem, it says it's compounded annually, so your N is 1, and we want that to happen in 5 years. So make your T 5, and we get 0.0844. Okay, problem F says, what continuous interest rate would you need to receive so that your principal increases by 50% in 5 years? Well, let's check it out here a second. Continuous interest rate, that's over here. Increase by 50%, so if that's $1, this needs to be $1.50, because it's an increase by 50% and it's in 5 years, so make the T 5. And we get this, 0.081. Notice it takes a lower interest rate if it's compounded continuously compared to right here if it's compounded annually. It takes a higher interest rate, 0.084 here. Okay, problem 1G says, what annual interest rate would you need to receive to equal an interest rate of 3% compounded quarterly? To equal an interest rate of 3% compounded quarterly. So let's go to this area, and it doesn't really matter how much money we put in, just so we're consistent on that. And it said 3% compounded quarterly, and we'll just let that be for 1 year, and we'll get this amount right here. Now the problem actually said, what annual interest rate do you need? Okay, so now here's what we get if we invest $1 at 3% compounded quarterly for 1 year. So let's figure out what rate we would need to get that same amount. So right here I'm going to do equals this amount, same amount of money invested. It's now invested annually for 1 year. Got to keep the time and the P the same, and I need 0.0303. So you need a little bit higher interest rate. This would be like a 3.03% interest rate if it's compounded annually is equal to a 3% compounded quarterly. Problem H says, what continuous interest rate would you need to receive to equal an interest rate of 3% compounded quarterly? Okay, 3% compounded quarterly, we did that right here already on the last problem. Now we're talking what continuous interest rate would we need, so we need to go over here to this area, and I'll type in equals, and I'll click this cell right over here. I think it's B13. Hit enter, so it puts that amount in here. $1 for 1 year, and it would only require an interest rate of 2.9%. Okay, and problem I says, which is better, getting a 3% interest compounded annually, or getting a 2.9% interest rate compounded daily? Okay, well, let's check them out. 3% compounded annually. Well, you can use any amount over any amount of time. So I'll just use $1 for 1 year on both of these. And let's see here. It's 3% compounded annually, so the N would be 1, and we get $1.03. Now, if we do the same problem, let's see what we get if we do 2.9% and compounded, it said daily, 360. And what do we end up with? Well, 1.029. So still, well, 1.02942. So in other words, the annual interest rate of, let's double check this here a second. The choices were on the problem were 3% or 2.9%. Let me check it here again. Right here, okay, it just rounded it a little bit. I'll show more decimal points, I think is what's going on. Let me format the cell to show more numbers. Actually, I could leave it percentage and just show a couple more decimal points there. So there we go. So which is better? Well, actually the 3% annually is better.